In this video, we dive deep into session management strategies for microservices architectures. Whether you're building secure APIs, distributed systems, or scalable cloud apps, understanding how to handle sessions efficiently is crucial. Maintaining a session between two microservices can be approached in several ways, depending on the architecture, security requirements, and scalability goals. Here are some common strategies. Token-based authentication, Stateless, JWT, JSON Web Tokens microservices exchange JWT tokens for authentication and session management. The token contains user claims and is signed, ensuring integrity. Pros: stateless, scalable, easy to verify. Cons: token invalidation can be tricky. Flow: client authenticates with Service A, receives a JWT. Service A passes the JWT to Service B in the HTTP header. Example: authorization, bearer token. Service B verifies the token signature and processes the request. Session store, stateful. Use a centralized session store like Redis or Memcached. Microservices share a session ID and fetch session details from the store when needed. Flow: Service A authenticates the client and stores session data in Redis with a session ID. Service A passes the session ID to Service B. Service B retrieves session details from Redis using the session ID. Pros: centralized session management, easy session invalidation. Cons: requires additional infrastructure, potential bottleneck if not scaled properly. Service-to-service authentication, mutual TLS or API gateway. Use mTLS, mutual TLS, for secure communication between services. Combine with an API gateway that handles session tokens centrally. Flow: client authenticates via the API gateway. The gateway manages the session and injects credentials/tokens when routing requests to microservices. Microservices verify requests via mTLS without handling session logic directly. Pros: secure, reduces complexity at the microservice level. Cons: adds overhead with mTLS certificate management. Distributed context propagation, tracing headers. For complex systems, use distributed tracing tools like Jaeger or Zipkin. Pass trace IDs or correlation IDs through HTTP headers to track requests across services. Pros: great for observability and debugging. Cons: not a traditional session management approach but complements other methods. OAuth 2 with Token Introspection for secure APIs. Services validate access tokens via an OAuth 2 authorization server. Use introspection endpoints to check token validity dynamically. Pros: secure, standardized, supports fine-grained access control. Cons: adds latency due to token introspection calls. Choosing the right approach. Stateless, JWT. Great for high scalability and simplicity. Session store. Good when you need centralized control over session data. API gateway plus mTLS. Best for enterprise-grade security and management. Auth 2. Ideal for third-party integrations and APIs. Let me know if you would like a code example or deeper details on any specific approach. If you found this helpful, like, subscribe, and hit the bell icon for more content on microservices, cloud architecture, and DevOps.